Alright, so today we're in section 9.5, irrational numbers. And it's the counterpart to 9.4, which was rational numbers. So today what we're going to see with irrational numbers is that they can't be written as a fraction, okay? And they are always non-terminating and non-repeating, meaning they just go on and on without a pattern and they do not end. But whether it's rational or irrational, they're all real numbers, okay? So there's no such thing as like a fake number or something. Real numbers are all the numbers in the universe, whether it's rational or irrational. Y'all with me so far? Okay, so here's what's not in your notes. I kind of just added this in this morning because it's so important for today's lesson. You have to know your perfect squares and your perfect cubes very, very well. Because I'm going to ask you, what's the closest perfect square to this number? If you don't know your perfect squares, there's no way you're going to get it. Okay, so take a minute. If you don't know them very, very well, take a minute to write them down. Okay, your perfect squares and your perfect cubes. Okay, so let's just recite our perfect squares together. All right, here we go. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, and 225. And we know that a perfect square has an even square root. So each one of those numbers has a square root, a number that can be multiplied by itself to equal that number. And what you're going to see today is you're not going to see any of those numbers. But you're going to see numbers that might be closer to one or the other perfect square. And that's what we're going to find. So let's talk about rational numbers and then we'll move on, okay? If you say, Ms. Kenner, I looked at this number and I changed it to a decimal and it's rational, okay? You have to tell me, is it rational because it's an integer? Is it rational because it's a repeating decimal? Or is it rational because it's a terminating decimal? All right? Somebody give me an example of an integer. What's an example of an integer? Any integer. Negative 2. Negative 20. Negative 35. Negative 4. Positive 6. None of those numbers, though, had a decimal value. So an integer is either a positive or a negative number, but it does not have like 2.1. That would be a terminating decimal. 2.3 repeating. That would be obviously a repeating decimal. All of which are still rational numbers. Okay? So in example 1, we're going to classify. Does it say classify rational numbers? It says classify real numbers. What does that mean? Okay, is it rational or irrational? If it's rational, you have to tell me what kind of rational. Is it an integer? Is it a terminating decimal, repeating decimal? What is it? Okay, so let's look at this first number. Now this one's been kind of throwing people off today. All right, 0.121, 221, 222. See lots of 1s and 2s. Could you bet with certainty, 100%, what the next 3 numbers will be? No, you can't. You could guess and say, well, I think I see. No, there is no pattern there, okay? You can say, well, I switched the 2s around and then there's one. No. Okay, so that I've heard all those today, but this is an irrational number, okay? You cannot predict. There is nothing in this number that tells you what the next digits will be. So we will say it's irrational. Now, if it's irrational, you don't have to really give an explanation because it's the same one every time. It's non-terminating, non-repeating. I just wrote it on the first one, because that's the criteria that I'm looking for. Does it terminate? No. Does it repeat? No. So now let's look at the next number. What's the square root of 196?
13.
No.
Negative
No. Don't you get out your calculator.
14 is negative 14.
Thank you. Yes, that was on just yesterday. Most of you got that, okay? So the square root of 196 is 14, so negative 14. You have to evaluate that. You can't just look at it and say yes, rational or not, okay? Now that you're looking at this number, is negative 14 rational or irrational?
Rational.
It is rational. What kind of number is it?
Integer.
It's an integer. So you say rational, integer. Okay? By saying what kind of rational number, I know you did not guess. Or if you did guess, you had to guess twice. Okay? It's an integer. So now the cubed root of 2. What do you think? Exactly. You think that's going to work out evenly? Could you write it as a fraction? No, you could not. It's irrational. Okay? Now the next one. Well, didn't we learn in 9.4 actually how to write a repeating decimal as a fraction?
Yes.
So because I can write a repeating decimal as a fraction, this is a rational number. And then you will classify it as a repeating decimal. Okay, so really, that's the criteria. Can you put negative 14 into a fraction? Absolutely. Negative 14 over 1. All right. What about our old friend pi?
It's rational. Irrational.
It's probably the most famous, if there is a famous math number, okay, irrational number. Okay. Cube root of 15. Think that's going to go into a fraction? No. Okay. 15 is not a perfect cube. This is irrational also. All right. How do we do? You have a section like this on your homework. Okay. So to classify it, you will either say rational or irrational. If it's rational, you need to tell me what kind of number. Okay? All right, next example. In example 2, I need to approximate. Oh, I like that word. What does approximate mean?
Exact.
It means not exact. It means rounded. So I don't have to stress myself or worry about the square root of 71, okay? All I need to do is figure out, okay, approximately to which perfect square would it be closer to? So what I need to do is I need to look at 71 and say, what is the next closest perfect square that is less than 71?
8.
The perfect square, though. What's 8 times 8?
64.
64. So 64 is just less than 71. So here's how you're going to write it. All right, you're going to say, oh goodness, I just lost it. There it is. Okay, the square root of 64, because we're saying 64 is pretty close to 71, is less than the square root of 71. But now let's figure out on the high side. Okay, so above 71, what's the closest perfect square?
81.
81. Okay, so between those two perfect squares, which one is closer to 71? 64, because there's only 7 units between those two, but there's 10 units between 71 and 81. So because 71 is closer to 64, I'm going to say the square root of 71 is approximately, and what did you say was the square root of 64? 8. Okay? Without a calculator, without anything. Because that was the closest perfect square that it was basically drawn to. It's 8. Now, on the 10th, we could make a table of values and play with, okay, which one is it going to be, is it going to be 8.2? Is it going to be 8.3? I will let you use your calculator for the 10th because I'm not really concerned about that ballpark like I am about the whole number. Now, if you don't have this, and this is how I graded it last year, and it's really important. If you don't have the closest perfect squares, I'm not going to give you credit, okay? on a homework or a quiz. So I want to see that, but then you can use your calculator for the 10th. So go ahead and find the square root of 71. It's not going to be a whole number, we know, because it's not a perfect square. But we're going to round it to the nearest 10th. So on this, really, I'm testing you on your rounding skills, which hopefully are very strong. All right, what does it round to?
8.4.
8.4. It was 8.42. Yes, 4.2. So that 2 lets the 4 rest. Okay, we don't raise it. All right, so now we have negative square root of 24. We're not going to worry about the negative yet. Okay, what would be the perfect square that's closest to 24 but less than 24? 16, okay? So we would say the square root of 16 is less than the one we're going for, 24, okay? Which is less than what was the square root? 25. Well, which one is it obviously closer to? 25, okay? So the square root of negative, so we're going to put that negative back in there. Negative 24 is negative 5. Or again, the approximation, are you writing your little squigglies? Okay? It should not be an equal sign. That squiggly equal sign means approximate. Okay? Now what would the 10th be? What would the 10th be? 4.9, because wasn't it 8, 9? So the 9 bumps the 8 up to a 9, so it's 4.9. So we definitely have to make sure we're rounding. Don't forget to make it negative. Okay? All right. So now I want you to do the last one with your buddies that you're in groups with. Okay? So let's go ahead and pause here and do this one together. High and low, we had 4 and 9. It's clearly closer to 9, right? Okay, so then that's the square root of 8 would be about 3 or 2.8. 3 and 2.8. Who got that? 3 and 2.8? Good job. Okay, next one. So now I'm going to compare, okay? And notice what it's asking me. Which one is greater? So is the square root of 35 greater or the cubed root of 80 greater? Well, in order to do this, I'm going to approximate both of them, which means I've got to know which perfect square or which perfect cube it's closest to. Okay? So can anybody tell me what is the perfect square closest to 35? 36. Right? So would we be accurate to say it's approximately 6? Okay. What about the cubed root of 80? I need the perfect cube that's closest to 80. 64 is on the low side. 120, oh, that's 45 away though. 64 is only 16 away. You see how 64 is closer to 80? We're looking perfect cubes. What is the cubed root of 64? 4. Okay, now, it's not going to be quite that, but it's not going to be 5 either. Okay, so clearly based on this, which one of these two is bigger now that I've estimated?
35.
The square root of 35. Okay, you must show the estimations on your homework, quiz, and test. If all you do is box in square root of 35, I'm going to think you flipped a coin and guessed. Okay? To show me the approximations shows me you had some way of calculating it. All right? So what do you think about the square root of 8? What do you think? 3, right? Because 8 is closest to 9. Is that not making sense?
No.
What perfect square is 8 closest to?
Oh, no, I mean 3. Oh, 9.
It does make
Yes,
sense?
I mean,
Okay.
like,
All right, so we all would agree that this is going to be approximately 3, right? Because the square root of 9 is 3 and 8's pretty close. Or what's the value for pi? 3.14. You might say, well, this is really close. Are you sure? Well, technically, the square root of 8 is not going to be 3, right? Because the square root of 9 is 3. So the square root of 8 is less than 3. So it's actually not that close. All right, which one is definitely bigger? Pi. Okay? But again, this is my reasoning. It might just seem like a little bit of chicken scratch, but it's not. It's more than that. Okay? You have to have the approximations. Go ahead and do the last one. Pay attention to your negatives, because that will definitely affect which one is bigger. Okay, so Maddox put negative square root of 2 is going to be about negative 1. Do you guys agree? It's closer to 1 than it is to 4. All right, perfect squares. What about the cubed root of 10? Yes, very good. Did you guys put negative 2? Because that's real close to 8, right? So negative 2. So which one is greater?
The negative 1.
Yes, so negative square root of 2. Okay? Usually, and I'm not going to say always, but a lot of times the square root of something will be larger than the cubed root of something. Because the cubed root has to be multiplied 3 times. Okay? Not always, though. All right. Did well. You have a section like that on your homework tonight. You do okay with it? All right. So now the last thing is to use the Pythagorean theorem to find the distance between 2 points. We actually have already done this using our slope formula, except it worked out to be a whole number. Now we're going to round to the 10th. So do you guys remember doing slope here? And when we find the rise, that's the height of our triangle. And when we find the run, that's the length of our triangle. All right, so go ahead and put these numbers into your slope formula. Do you guys remember slope? y2 minus y1 over x2 minus x1. Go ahead and plug them in. Okay, so slope, okay, negative 5 minus negative 3. Did y'all catch the double negative?
Yes.
Over 3 minus negative 4. Okay, double negative changes to a positive. What's negative 5 plus 3? Negative 2. And what's 3 minus negative 4? 7. Okay, so this is my rise or my height of my triangle. This is my run, my change in run, or the length of my triangle. Okay, so now height and length, that's my A and my B. I'm going to plug them into Pythagorean theorem. Negative 2 squared plus 7 squared equals C squared. Now, the good news is distance is always going to be that C value. So what's negative 2 squared? What's negative 2 squared? 4. And what's 4 plus 49?
53.
Yep, 53. So just like we predicted before we started this, is 53 a perfect square? No. So all our Pythagorean theorems before, they were nice and perfect. This one is not. So we will approximate to the nearest tenth. Square root it just like we have. And C is approximately, what's the square root of 53? 7.3, because we have to round it. 7.3. Okay? You have one problem like that on your homework tonight. All right? If you understand that, that is everything you need to know for 9.5.